start recording. Okay, the next example is this is the next example, the simple alternating current generator. So let's paste it here. The application, the AC generator. An AC generator is made as shown in figure. The coil contains 500 turns and is supplied with a sinusoidal current of amplitude 10 ampere and frequency of 60 Hz. The relative permeability of iron is mu r is 1000. The loop is 10 by 10 and rotates at 3600 rotations per minute. Assume the flux density in the gap is uniform and perpendicular to the iron surfaces, and the B curve is linear. Calculate the electric motive force of the loop. What is the waveform of the electric motive force? Suppose you need to generate 10 volt output peak using the device. How many turns are required in rotating coil? Okay. Sorry. Do I need a toolbar? Probably no, I don't need it. Okay, first question. We need to find the electric motive force of the loop. In order to find the electric motive force of the loop, we have to apply previous knowledge that we have studied, which is electric motive force in the loop is the sum of electric motive force due to the motional action plus electric motive force due to the transformer action. And so let me start. Okay, we are dealing with question A. The electric motive force is the sum of electric motive force due to the motion plus electric motive force due to the transmission action. So electric motive force due to the transmission action is also called as electric motive force due to the change of flux. In order to find this, first of all, we need to find the magnetic flux density in this region, in this air gap. Magnetic flux density B in this region is equal to the relationship between magnetic flux and surface area of the gap. So from the previous course, from the course of electrical equipment, the magnetic flux through the gap was equal to N multiplied by I divided by reluctance of iron plus reluctance of air gap delta, and multiplied by S, and is equal and multiplied by I over sorry, and multiplied by I the reluctance was given as L over mu over mu S, and S is surface and S is constant everywhere. The cross section area is assumed to be constant everywhere, and S simplifies, and what we have length of material medium mu 0 mu r plus length of air gap. Here we use only mu 0, and this is equal to, okay, let's compute numeric values. So B is equal phi over S. We set n multiplied by I over length of material media over mu 0 mu r plus length of air gap mu 0, and this equals number of turns is given as 500 turns multiplied the current is given as, okay, it is in the problem it is said the coil is supplied with sinusoidal current of amplitude 10 ampere and frequency of 60 hertz. Okay, amplitude is 10 ampere multiplied, it is said sinusoidal, we can write sine or cosine, it doesn't matter, let's write sine, and the frequency of 60 hertz. Okay, if f is 60 hertz, omega will be 2pf, and it will be 120 pt. And divided by the length of okay, let's look here, the length of iron legs, here, okay, here is 0 0.3 0 0.3 0 0.3 plus 0 0.1 plus 0 0.1, is equal to 0.9 plus 0.1 point okay, this is 0.01. Okay, it will be 0.333 plus plus 0.29. Okay, and it will be the ln. This will be 1.19, and this will be 0.01. Okay, 1.19 over let's write mu0 mu r plus 0.01 mu0. And if you compute the numeric values, using your calculator, you will get b equal to 0.5615 sine omega t, or omega is 120p. Okay. So now the electric motive force is calculated from the where was our no. Okay, motional, not flux here. Electric motive force due to the change of flux is calculated with this equation, and if we apply this equation here, in our case, electric motive force will be omega 2 multiplied by S n number of coils of the loop. Don't confuse with number of coils in the coil. S n P0 cosine omega 2 t by multiplied by cosine alpha, where the omega 2 is this one, 120, and alpha, so alpha is omega 1 t, where omega 1 is computed from the rotation of our coil, not coil, of our loop, which is given that our loop is rotating at the speed of 3600 rpm. So the omega 1 will be Pn over 30, which is 100 and 1. Well, we are quite lucky that omega 1 and omega 2 are equal and is equal to 100 and is equal to 120p. Okay, let's compute the EMF, electric motive force. So pay attention, this is due to the transformer action. Okay, let me write here electric motive force due to transformer action, we said, is equal to omega 2. Omega 2 is equal 100. Well, here we forgot about minus. So omega 2 is 120p minus 120p multiplied. S is 0.01 multiplied 0.01, 0.01 squared multiplied. Sn is 1. So B0 cosine omega 2t. B we found as equal to, okay, here, yeah, B we found equal to this value, B0 0.5615 multiplied by cosine 120 pt multiplied again cosine 120p. We can write here cosine squared 120 pt, and this electric motive force due to the transformer action will be, if we compute all this, will be minus 0.0212 cosine squared 120 pt. Okay, we found electric motive force due to the transformer action. Now we need to find electric motive force due to the motion action, or in other words, due to the rotation of our loop. Electric motive force due to the motion action is okay, more or less similar, but we have omega 1 s and loop multiplied b0 instead of cosine. Now we have sine omega 1 t multiplied sine omega 2 t, sine omega 2 t. So we already know that omega 1 is equal to omega 2, and we put the numbers here. Omega 1 is 120 p, s is 0.01 squared, n is 1, b0 is 0.5615 multiplied sine squared omega 1 t, and the final answer of electric motive force due to the motional action will be 0 point, okay, 0.0212 sine squared 120 pt, and total electric motive force will be sum of electric motive force due to the transformer action plus electric motive force due to the motional action, and we have minus 0.0212 cosine squared omega t plus 0.0212 sine squared omega t, and is equal to minus 0.0212, okay, cosine square minus sine square gives us cosine 2 omega t multiplied cosine of 2 omega t. This is the final electric motive force in our problem. So the next question is, what is the waveform of electric motive force? The waveform of electric motive force again is sinusoidal. You can see that the law is okay. Here we can see that it is changing by cosine, and waveform is sinusoidal, but the frequency is twice as frequency of rotation or of the frequency of alternating current. So we have the third question in our problem also. Let's go to the third question. Where is the problem? Here is the problem. Okay, the third question is saying copy here, paste. So third question is saying, suppose you need to generate a 10 volt output peak using this device. How many turns are required in the rotating coil? So our final electric motive force we found that was equal to minus 0.0212 cosine 240 pt. Okay, here the electric motive, the maximum value of electric motive force, or we can say EMF 0, here is equal to 0.0212 volts per turn, or it means if you have one turn, the peak value will be this amount, and we need peak value of 10 volt. We need the peak value of 10 volt. In order to find the number of turns which are needed to reach this peak value, we need to divide 10 volt by EMF 0, or by the peak value of one turn, and we have 10 volt divided by 0.0212 volt per turn, and we have the number of turns is 471.7 turns, or we have to round until the next until the next integer, and the number of turns will be 472 turns. Okay. Well, do you have questions regarding today's lesson? You may write, or you may ask by voice. It will be better if you write. Well, does anybody have questions? No? Okay, good. In that case, good. Well, in that case, we can finish for today, and in the next lesson we can we will start the transformers.
Ustoz, buni nimasini tashlab yuborasizmi?
Boshdan so'rang. So wait.
Hali hozir yozib oldingizmi buni?
Of course.
Tashlab yuborsangiz hozir ish chiqib qoldi-da, shu ish